Hey, out there in Pirate Geometry Nation, Mr. Mitchell coming to you with a brief video. I want to show you how to build something. There should be instructions in your Google Classroom for what you're going to do on this assignment. This has to do with trigonometry, and we need a tool at home and in the classroom, but especially at home, that can read an angle. Okay. I've seen this called different things. Clinometer is the most common one I come across. Clinometer. There's one right here underneath my picture. Okay, so I'm gonna make this go away. I'll see you later. Here's a clinometer. All right, here it is just sitting on a piece of paper. And what's here is a weight. And what this thing does is, let me move this giant mouse out of the way. It creates a tool that can help you read an angle. So the weight is governed by gravity hanging down. And if it's hanging down towards the center of the earth and motionless, and your straw is horizontal, parallel to the surface of the earth, it will read a value of 0 here. And I've written this 0 in. That's important. I've written this in as a 0. Now, clinometer. What happens when I hold this and I look through one end of the straw, and then I look up into the sky? So my eye's here on the right, and I lift my eye to see something in the sky. You will see this orange line shift back and forth depending on how high the angle is. So this would be an angle of 30 degrees. Okay. Hopefully in class you're getting a picture of what these look like and how they work. And for the people at home, we are going to build one here, and this video could help people in the classroom too. But we're going to build this piece, this clinometer, and it's going to have some features that will tell us an angle. Okay, so here held flat, I look up through the straw here, and that would be a 20-degree angle with my weight hanging down due to gravity. I put my eye over here and look that way. That would be a 35-degree angle looking up that way. The number you get will always be between 0 and 90 if you're sighting something on the surface of the earth that is above your head. And that's the objective for trigonometry, to estimate the height of something that's too much of a hassle to climb up and drop a tape measure from. Okay, this is our end product. I'm going to clear my desk and we'll just chat. Directions are here. They're in the Google Classroom for those of you at home. And so you have a template that you can cut out. So I'm going to cut along the line, the top of my protractor. Okay. And then I'm going to give myself a little bit of a margin when I cut around it, so I can add a little extra labeling. Because this protractor has numbers on it, but we're going to be using it upside down. So we're going to kind of relabel it. So there I've cut out the shape of a protractor. Carefully cut around the edge of the protractor shape above. Glue the protractor onto a piece of cardstock paper or cardboard. The flat edge of the protractor should be lined up flush with the flat edge of cardboard. Cut out the shape once again. Be sure to leave a 1 centimeter margin for labeling. Okay, so I have about 1 centimeter there. Could be on your cardstock or your cardboard when you cut it out. So let's see, I'm going to hold it flush, it said, to the end of the paper like that. On the full assignment, there is a materials needs list for this project. And so if you're at home and you want to try this rather than do trigonometry problems, well, see if you can figure it out. Turn in something we can have a look at and have yourself a project as a virtual student from home. So I'm going to line this up, okay, flush with the top there. I'm going to let that dry for just a second. I need to grab a straw. Okay, I'm back. I have a straw. All right, so I'm going to, looks good enough. I'm going to cut it out. It's flush with the top of my paper. Any last adjustments, slide it a little bit. I like how that worked out pretty well. Cut it out. Since I left my margin on my white paper. So the purpose of the backing is just to make it kind of firm when I take it outside and use it. A piece of paper would be too flimsy, but something like a cereal box would be ideal. Open up a cereal box, use the cardboard in there. Okay. Now, where is my piece here? Okay. Any string will do, or monofilament fishing line if you're okay with knots. All right. The purpose here is to create a weight that you can use with gravity. I'm thinking today I'm going to try a penny. Okay, so I'm going to try a penny for weight. Those are easy to find. I'm going to take a piece of Scotch tape, put it there on the penny. Okay, and then I'm going to line this up so that a little bit of string gets trapped under the tape, like so. And then I'm just going to wrap that around again. Okay, so my penny hangs. It feels solid enough. That's going to do the trick. Okay, now there's something interesting that's going to happen here. I lay this. This is where my swing is going to come from. And what I want to do is first kind of tape it down. So I'm just going to take a little piece of tape here. And it needs to swing from the black dot. That's where we want our penny to swing. That is the 0 for the protractor. So the edge of my clear tape is now right there where that black dot is. And if I hold this close, you will see that this is swinging from the black dot, the center of the protractor. Okay. Wow, I kind of got that first time. Maybe I'm just so nothing rips or moves, I'm going to put a second piece of tape just under that one, and I'm hoping that's going to be enough to hold it in place. And now I have a pretty good spot. And when this rotates, it is from the black spot on the protractor. And the ones in class we have a hole right there. That is where the origin of an angle is, a vertex. Okay, we're almost done. We need the sight. So like looking through the sight on a rifle, you have kind of a scope on top. This is what you look through with your eye. I'm going to cut my straw. Off it went. Roughly to the length of the protractor. And I'm going to grab a couple pieces of tape here. Okay. And so I'm just going to tape the sight, the straw, to the top of my protractor, like that. Just a little tape to hold it down. And there we are. Now, I mean, mathematically, you want to be right on top of that, so you might have to fiddle with it to get it so it looks like it's running right down the bottom edge, or what is here the top edge of the protractor. But that's what you're going to look through. Yeah, I can see through it. And I want to hold it. So keep taping until it looks like it's sitting right on top of the protractor. And now you have a clinometer. If I start, it's funny when I'm looking at a camera that's down, but if I rotate, I can see the angle start to change. Okay, so now that you have one in your hand, you can kind of see, hey, when it's horizontal to the earth, that is a flat angle, a straight angle, excuse me, a flat angle. That's 0 degrees. Horizontal to the, parallel to the earth, a horizontal line looking to the horizon, that is a 0 degree angle. I don't have any incline at all. So where it says 90 on a normal protractor, this is a 0. These are accurate marks of angle. And depending on whether you look through the left side or the right side, it's going to be a number between 0 and 90. So I'm going to add my labels here. That will help me. Boy, if I look at something in front of me that's more than 60 degrees, that's going to be it's like bend my neck pretty good. This would be 10, 20, 30, 40, 50, 60 in the other direction. This just means I can look through either side of the clinometer. You know that question your parents sometimes ask you, like, what'd you do in school today? And your answer is, whatever, I'm going to my room. Well, you could say you built something. I suppose the ancient Greeks had to figure this out to measure angles for themselves. And here in modern times, you can find digital tools that will do this just the same. They can measure an angle that is an incline from the horizontal surface of the earth. This would be a reading of 20 degrees on my inclinometer. I'd be looking through the straw on the right side, and it would be an incline of 20 degrees. When you look through it, you'll just let that penny or weight, fishing weight or nut, whatever it is you tied down there, you'll let it kind of stop swinging. You reach down, and I like to pinch it right where it is because I'm looking through this side, and then I can bring it down to read it. Okay, 20 degrees. If you can be even more specific, you know, if it's here, well, maybe it's 20.5 degrees. You can be as precise as possible. This is going to be the base of your trigonometry. You will have one angle to measure, and then you'll need to figure out one side of your triangle. One angle and one side in a a right triangle. If I have both of those things, then I can figure out everything else, all the other angles and all the other sides. The classic scenario in trigonometry. And this is how I would try to set it up to do your estimates at home. The classic scenario is a right triangle. Okay. Find the angle here. Estimate the height of an object here. And then you'll need a distance on the ground from a tape measure. So this will be a distance you can actually measure by pacing off walking out a measuring tape. Get this distance and this angle, and now you can find X. In this case, you really will be in the picture yourself. You'll be there looking through your straw, read the angle, know this distance, estimate the height of the object that you just looked at. That's going to be what we're after 3 times in our exercise. There is more instructions on the sheet. I'm hoping that this has given you A, your angle measurement tool, and B, a little hint on how this goes. Boy, you know what? If I'm here, let's go all the way with a hint. This sure looks like the opposite side of my triangle, and this looks like my adjacent. So I can do some tangent math with this angle and come up with an estimate for X. Good luck, geometry classes. I hope you guys do well. Bye for now.